I'd like to welcome Matteo Merli and Sijie from StreamNative to the stage.
Good morning, good afternoon, good evening, everyone, depending where you are. Welcome to Pulsar Summit Europe 2024. I'm really excited about this event. First, it's well packed with great talks. Thanks to all the speakers for putting all these talks together. Secondly, it also always feel great to kick off the Pulsar Summit together with my partner, Matteo. Lastly, we also have some exciting updates to share today. So we're going to talk about our new data streaming engine, re-architect for today's cost-conscious economy. So let's get started. Before I dive into it, it's important for us to kind of revisit how data streaming, in general, data infrastructure software has been built and evolved in the past 25 years. So if we go back to 2000, in the first 10 years, from 2000 to 2010, it's the on-premise time, a time categorized by on-premise deployments with slow network. Infrastructure software from this period was optimized for wreck awareness to compensate for those limitations. Hadoop was one of the greatest big data software that was created during this time. Kafka, created as an ingestion tool to ingest data into Hadoop, was originally developed at LinkedIn during this time, and it was open source in around 2011. So this is the first 10 years where data software was built for on-premise deployment with the mindset of coupling computation and storage together to optimize for slow network. So if we fast forward to 2010, the landscape has drastically shifted, particularly with the move towards cloud-native environment. The infrastructure has changed so significantly. For example, networking became really fast, moving from 1 gigabytes network to 10 gigabytes network and even more. The system design is shifted from designing from physical machine to virtual machine to containers. All the deployments are evolved towards containerized deployments. In order to embrace the power of cloud and cloud-native technologies like Kubernetes, infrastructure software from this period was optimized for scalability over networking cost. This shift led to the widespread adoption of architectures that separate compute and storage. And a great example is shown as like Snowflake in Databricks. So with the landscape has drastically shifted and Kafka became very popular. However, Kafka's core architecture has remained largely unchanged. Organizations have attempted to transition Kafka to the cloud, but the reality is that Kafka is costly to operate at scale in modern cloud settings. In contrast, we built Pulsar in that time by embracing the modern cloud-native environment with a mission to re-architect Kafka for cloud-native era. So we have asked ourselves several questions. So if I start from scratch and we implement Kafka for this cloud-native era, well, what we will do? As Kafka was born in on-premise era with a compute and storage coupled architecture, there were a lot of challenges in running Kafka in this cloud-native environment. So we have asked ourselves, what if I can design a system that is able to scale the clusters horizontally without worrying about data rebalancing? That would completely get rid of all the problems and pain points result from data rebalancing. Secondly, Kafka was originally designed for data ingestion to Hadoop. It provides a simple log-oriented API. While it's simple, it's also like a lot of functionality that traditional messaging queue provides. So enterprise end up using Kafka for data ingestion, building out data pipelines, and at the same time, they keep using RabbitMQ, ActiveMQ for these business-oriented applications. So we have asked ourselves another question. If I can provide a platform that just store one copy of data and allow consuming it multiple times for different use cases, that would completely get rid of the need for running multiple different technologies and keeping data multiple times in different systems. Last but not least, Kafka users end up running multiple Kafka clusters in an organization for different teams. So what if I can just provide one multi-tenant solution that is able to reduce hundreds of Kafka clusters into one single cluster? So all these questions lead coming up together that creates Pulsar. So let's take a look at what's the difference between Pulsar and Kafka. So before Pulsar, Kafka deployed in a monolithic architecture where compute and storage are coupled. It's partition-centric. All the data stored one partition in one same node, which result in extensive data transfer during cluster scaling up and down, as partition are required to rebalance from one physical machine to the other. With Pulsar, we separate compute from storage and change the architecture from a partition-based architecture to a segment-based architecture. With this change, we don't need to rebalance data at all when scaling up. So you can scale 1,000 times faster than Kafka. This results in the first unique differentiators between Pulsar and Kafka. That is, the system is cloud native, it provides instant scalability, it guarantees resiliency, it provides much lower latency. Secondly, before Pulsar, an organization ended up using multiple technologies, using messaging queue for building business applications, using Kafka for building pipelines and data services. You save multiple copies data across different technology within an organization. It's a waste of resources. Also, data is inconsistent between different systems. You have to spending a lot of engineer hours in order to address that inconsistency. With Pulsar, everything is all in one system. It provides a unified messaging model that supports both messaging queue and data streaming. So you can save one copy of data and consume it multiple times with different consumption model. It provides much stronger consistency about data contract between different applications and services, and also resources are highly optimized when using one technology. This brings us to the second differentiators that Pulsar brings to the table, which is a unified data streaming system, provide both queuing and streaming. You can only save one copy of data and consume it multiple times. Thirdly, before Pulsar, and within an organization, people might be managing so many different Kafka clusters. They build each clusters for each team. So you end up have hundreds or even multiple hundreds of clusters within one large organization, and each cluster is over-provisioned. And data is also segregated in siloed. If you want to share data between different teams, you need to set up bespoke integrations of moving data from cluster A to cluster B, which will result waste of resources, and there's an extensive network cost between data transfer between different clusters. With Pulsar, it's a multi-tenant solution. You can easily map different teams into one large clusters. So there's one single cluster to maintain and operate. There's no more over-provisioning on resources. It's much easier to share the data because it's in one cluster. Putting all this together with the hard questions we asked earlier, it led us to creating Pulsar, which is a cloud-native unified multi-tenant data streaming technologies. So to take the technology further, we were the first in the market introducing a concept called tier storage. Essentially, it was to kind of moving the hot data, warm data towards a much cost-efficient cloud-native storage that we are able to leverage object storage for long-term data retention. And the entire system is designed to seamless moving data between different tiers with an automatic tiering policies. So taking that into consideration, by comparing the re-architect Pulsar with Kafka, we actually achieve, we are able to scale 1,000 times much faster, providing guaranteed SLA and achieve 2.5 much higher throughput. We are able to achieve much lower latency with a total cost reduction of 60%. Now, moving to 2020, we are getting into a completely different era. So in today's environment, there's a heightened focus on operational efficiency and cost reduction, which has slowed down the migration to cloud solutions, and in some cases, even reverse it. So we navigate through a much complicated landscape nowadays, which have both on-premise and cloud deployment, where cost and network efficiency are critical considerations. This scenario underscores the need of shift towards more cost-aware, sustainable architectural approaches into data streaming services. So to meet the evolving demand in current environment and further reduce the cost of running a data streaming platform, we need to revisit and possibly redesign the architecture we have been built with Pulsar. Although it's understandable that the focus has been shifted to cost, however, this emphasis often comes without the necessary context of the trade-offs involved, leading us into a vendor's trap, where cost discussion lack depth of context in utility. Noticing this gap, we propose what we term the new CAP theorem for cloud-based data streaming system. Essentially, the entire new CAP theorem refers to three properties that cloud data streaming platform needs. One is cost efficiency, availability for the system to accept reads and writes, and the performance tolerance. The theorem essentially states it's not possible to guarantee all the three desirable properties in one cloud-based data streaming platform at the same time. So Pulsar was originally born as an AP system, which is focused on availability and performance. In order to achieve ultra-low latency, it leverages data replication across different availability zones. However, nowadays, it would introduce a lot of inter-zone traffics. But with the design, Pulsar can also be deployed as a CP system with a single zone deployment, which more focus on lower the entire cost and still able to provide low latency. But because the system is deployed in single zone, you are trading off the availability over cost in performance. So we have to ask ourselves really hard question. While Pulsar can be an AP system, can be a CP system, but can there be a CA system, which means can we reduce the entire cost further while maintaining the high availability? So that's our biggest question in the current hybrid and cost-conscious world. Can we evolve Pulsar, what we have been built towards a more cost-aware, sustainable architecture? Can we follow the entire IT infrastructure changes to leverage object storage, data lakehouse ecosystem more? So to further reduce the cost to meet the evolving needs in the current environment, we need to revisit the possibly redesign the architecture that we have been built with Pulsar. So we have identified a couple areas that is from infrastructure, migration, integration perspective. So how can we really reduce the cost? So looking into the infrastructure cost first, networking often represents the most significant expense for a data streaming platform. Because Pulsar operates as an AP system, cross-AG traffic it occurs like substantial cost due to the nature of cross-AG replication to ensure high availability and reliability. This unfortunately come as a higher cost. The cost of the entire inter-AG data transfer from replication can become extremely high for high throughput workloads, accounting for up to 90% infrastructure cost if you are self-managing Pulsar or Kafka yourself. So we ask ourselves, is it possible to completely get rid of the cross-AG traffic from Pulsar? And that would significantly reduce the total cost of running Pulsar and Kafka. Secondly, Pulsar's modular design, which includes components like Zookeeper for metadata management, Bookkeeper for low latency log storage, but this can become really challenging for beginners. What if we can just replace those keeper services to simplify the operation? By combining all these aspects together, we can reduce a lot on the infrastructure cost. This brings us to the second areas around migration cost. Although Pulsar provides a unified messaging and data streaming API, some applications are still written using Kafka API. So if we can make Pulsar compatible with Kafka API, this will get rid of the needs of costly application rewrites. Thirdly, it brings us to the integration cost. So when we're looking into a data streaming system, the destination for this data streaming is data lake. However, these are two completely different systems with data storing in different formats with different schema. So you end up building tons of different type of integration between the two of these, which result in a waste of resources, including extensive network transfer between different systems and additional maintenance costs. So we ask ourselves, what if we can make data available in the lakehouse and it's ready to use, which can avoid bespoke integrations, eliminate the needs of transferring data from data streaming system to data lake. So putting all this consideration together, it remarks the beginning of our new journey to re-architect Kafka in Pulsar, aiming for a more cost-efficient data streaming architecture that aligns with our industry's evolving needs. So with all this, I want to hand over to my partner, Matteo.
Thank you, Sijie. And hi, everyone. It is very exciting today to be able to announce Ursa, because Ursa is a combination of a lot of efforts we have been doing in the past few years as StreamNative in order to rethink and re-architect a large portion of the technology that powers our services. And without further ado, let's get check and what Ursa is. And is kind of like a re-architecture of some of the core components, but with this redesign for the new era of this cost-conscious data streaming. And the first step is a fully Kafka API compatible protocol that is exposed, and that basically allows you to have migrate all your applications without changing a single line of code. Like this 100% compatible. It supports all the features from schema registry to any other complex corner case features of Kafka API protocol. And with that, you can basically get and integrate StreamNative and with Ursa in all the Kafka ecosystem out of the box. No extra steps required. So this is kind of like a major foundation to kind of like expand the entire ecosystem that you can access in from StreamNative Cloud. The second core pillar here is the redesigned to be Lakehouse native. When you have data ingested into streams, this data will be now instantly available in a structured form in your Lakehouse format. That means the first realization here is that the concept of tier storage is gone in a way. There is no concept of data tiering anymore. The data is not in like a first tier and second tier depending on size and age. Instead, it is instantly available. And when it is instantly available, it means that it is also available to all the Lakehouse compatible tools, which is a huge ecosystem that lets you analyze and access the data in multiple different forms. And it is in a standard and compatible format. So it is not anymore tied to a particular proprietary data format. These are all very important aspects of it. And the last one is the no keepers, as we call it. This essentially is a re-architecture of the core storage of Pulsar that has eliminated all the zookeeper and bookkeeper component. That means that the architecture right now it is much more simple, nimble, and the cost of managing all these components has gone way down. There is no extra component, and also the other two important aspects here are around the inter-AZ traffic. As most of people know, that the traffic within different availability zones in all cloud providers, it is paid. So every kind of like access that you do when you're using bookkeeper and zookeeper or any kind of like a local storage solution will incur into this AZ traffic. But with Ursa and we will not have any local storage, and we will not have any extra cost related to inter-availability zone traffic, which is kind of like a big deal, as this is like one of the dominating factor in the infrastructure cost. And finally, there are no more disks to manage, no more local disks, and this also is a huge improvement in terms of manageability and also in terms of cost and also scalability in like elasticity of the cluster as a whole, right? We don't have any more problems with disk getting full or having to add capacity in a more complex way. It is instant scale up and instant scale down all the way. So these are the three pillars of the architecture that is announced as Ursa today, and the three part. Kafka API compatible, 100%, and Lakehouse native, and no keepers. And there is one extra part that is important in this architecture, which is no migration cost. As in that we want to make sure that everything is available in the most compatible way through that can tap into all the existing ecosystems and all the existing tooling that all the technologies are using. And Ursa didn't come out in one single day, wasn't built in a day, and it has been gone through multiple phases. First one, the Kafka API compatibility. That's again, that protocol is everywhere. We made sure that it is like a first-class citizen right now in Ursa. As long as with the Pulsar protocol and all the Pulsar ecosystem. Lakehouse storage is the second pillar here, and The third one is the remove keepers. And after that, there's the fourth phase here is the tying, like a bidirectional tie between a stream and a table, so that data in a stream can be seen as a table, and data that is accessed as a table and modified, not just accessed and in a read form, but also modified, can be seen as a stream. So that is the fourth part here. So if you have to resume what Ursa provides is kind of like easier, faster, and cheaper. Easier because there are less components, less moving parts, less things to manage, less things that can go wrong. Faster because its performance is not compromised by this architecture. Actually, it will give you much better performance, and with like instant scalability. And cheaper because we make use of cloud storage instead of local storage, and also because we can really size it to what you use and not having extra capacity because of the architecture with local volumes and the local storage. So everything can be scaled down and scaled up very quickly. That means that in the end, the whole infrastructure cost is way cheaper than it was possible with an existing solution before. And if you have to look at what Ursa is and provides, is actually the building block for a bigger and more grand data streaming vision that we are building at StreamNative. And that goes around multiple axes here. So the stream, the connect, secure, and everywhere. The stream itself is a core component, is a foundation, upon which everything else it is built on top. So Ursa ensures that the data can stream efficiently and with seamless scalability at a fraction of the cost. Instant scalability, no network cost, very much lower storage cost. The connect part revolves around how can data be similarly integrated with in the stream with multiple different systems, and we can announce multiple different improvements that we are like rolling out on this front. And the first one is the unified connector framework, which is in private preview. The unified connector framework means that we are now able to support, as well as Pulsar IO connector, we can also support directly all the Kafka Connect based connector and run that in a seamless and similar way. So that kind of like expands the number of available sources and sinks that we can deploy in our StreamNative platform, and is a very complete set of connectors. The second one is the generic function runtime. That means that we are able to right now to add more different function runtime with different languages that we can easily support additional languages in a much easier way. Before it was Java, Python, and Go. Right now we can add more and more languages in a much seamless way. And similar in a different flavor here is the support for WASM function. So you can deploy WASM function, and again they can be built in multiple languages and deploy as with WASM. So this it's kind of like enables a lot more flexibility in terms of the function runtime and the connector runtime. The third aspect here is the secure, and we did in the past year a lot of effort around role-based access control, and this goes all the way from the Stream API level, topic API levels to our StreamNative Cloud UI, and you can define really fine-grained and control every single operation, who has access, group of access, who has access to write data, read data, see metrics about the data, and every single asset in the platform can be controlled with this mechanism, which is very powerful. And finally, we want to have this platform, this service everywhere. And that means that Ursa will be available in all of our product offering, both from hosted cloud to the bring your own cloud managed service, as well as in private cloud. So really, you can take all these advantages and all this technology that we have built, and we can deploy it in every single different delivery mechanism of our product. And when we say deploy everywhere, is also that we have added support for Azure. So right now we support AWS, Google Cloud, and Azure for both hosted and BYOC cluster. These are available right now in public preview, the Azure support. And so you can just go on StreamNative Cloud and create clusters in Azure. It is as simple as that. The second aspect is that we have improved a lot the flow on how our BYOC clusters are getting created. Right now, you can do basically self-service provisioning of your cluster from using APIs and CLI tools or the Terraform module. And we are adding as well support in the UI directly to have the BYOC creation. So you can get the permission and then use the Terraform module and provision the entire BYOC cluster and then manage it through our StreamNative UI without interacting with anyone else. So it is much quicker, easier, and you can get started and up and running in production in a matter of few minutes instead of having a lot of interaction back and forth. Finally, we say that this whole architecture, it is based on Lakehouse, and the data is available in Lakehouse directly. So the main advantage here is that you have the data in the streaming form. At the same time, you have this data available in a standard format that can be used from a huge variety of different technologies that can read and analyze this data through this Lakehouse catalog. And that will enable a much simpler architecture and also a much faster way of seeing extract value from the data, without spending a lot of time in any integration. You have your online transactional use cases. The data is immediately available in an analytical format for you to run analytics in real time over that same data without any extra step required, which is pretty powerful. And with this, I would thank you for listening to this keynote, and I hope you will enjoy the rest of the very interesting sessions today at Pulsar Summit.
Thank you for listening to our keynote, and hope you enjoy the rest of the sessions.